What's up, gamers? It's Game Theories, the channel where me, Camille, Joey, and our blobby friend, Dak Blob, explain through gaming theories and random science. Today we will be receiving the theories of soul sand and how the light and the heat from blue fire even works and how it even does.
Fire is typically a part of a system of energy released from electrons moving from valence to valence, which moves from a ground to excited state, giving off heat. When the excited state cools off back to the ground state, light is released. When fire is lit, energy is being absorbed and released rapidly, which keeps all electrons in a cycle, which keeps them from going excited to ground to excited to ground to excited to... you get the point. This allows for the heat and light to be released at about the same time. Typically, the fires that are seen in the news or in your campfire are orange, but the ones that are currently being referred to are the blue fires that are seen in cooking or in soul sand valleys. The reason that the fire is blue is because of butane, which allows for a blue fire to be combusted. Soul sand fire is typically a light blue-greenish color, which means that there is a second factor. But what could that second factor be? Copper chloride. When copper chloride mixes with fire, it makes a greener color. So if blue fire is being produced from butane, then soul sand also has copper chloride within it, which allows for the soul sand fire to be light bluish green. So realistically, if you go into a soul sand valley...
Oh my god, why does it smell like gas?
One last thing to note is that the more electrons move throughout the valences, the more energy and heat and light is produced. Yeah, that's all cool, but how can we even tell that the light is blue?
So the color wavelength of blue fire is typically shorter than that of other colored flames. The blue fire is typically between 450 to 495 nanometers. Compared to similar colors like green, it needs less energy because it is longer distance from the eye, about 475 to 570 nanometers. This shows how the blue fire needs more energy because it is closer to the eye, and it needs about 0.5 more energy than the color of green. It all depends on the light emission and the element mixed with it. For example, copper chloride, when it is burned, it emits a blue-like color. But an element like lithium and strontium would create a red flame. This would mean that the copper needs more energy to burn and emit a color like lithium, which would need less energy, about 0.84 more energy to light up. And as previously as Joey said, the more energy it takes in, and like different elements give out different amounts of energy. And according to the cycle, the amount of energy that electrons absorb, different amounts of energy is released, and that's what the colors are created. That's how the colors are created.
Whoa, so that's why we're able to see blue light, due to the waves that hit our eyes. But are there any real-life examples of this?
Blue fire might seem impossible to find naturally without any help of outside sources like people or machine. There are actually a few places that you can actually see blue flame in nature. There's currently two volcanoes that can emit blue fire. One is in Ethiopia and the other is in Indonesia. You may wonder how this actually happened and caused the volcano to actually produce blue fire, like blue lava. So actually, when the volcano erupts, the lava or the fire enter an excited state, which when it happened, the sulfur gases that trap inside the volcano actually got released into the oxygen, and when the lava and the fire come in contact with it, it causes to go back down to a ground state and emit a blue like fire which is visible to human eye.